All right, in today's video, we're going to be talking about covalent compounds. So we finished our discussion of ionic compounds, and I'll be honest with you right up front, ionic compounds are the most tricky. And the reason that they're tricky is because you got to make sure that the charges cancel. Sometimes you need a Roman numeral, sometimes you don't. There's those polyatomic ions that kind of make it a little bit more challenging as well. So I thought I'd start with the more difficult ones, and then the other two, covalent compounds and also acids, are a little bit easier than ionic compounds. Now, the problem is that you name them differently. So even though covalent compounds are pretty straightforward and pretty easy, it's really easy to mix them up with ionic compounds. So that's why the very first thing that you do is you must identify a compound as either being ionic or as being covalent, okay? Because if it's ionic, then again, you have to cancel the charges, you got to think about Roman numerals, the polyatomic ions, etc. If you identify it as being covalent, then we're going to learn right now how to do that one differently. So remember that in an ionic compound, there's a positive charge and a negative charge, and that's because the positively charged particle has lost one or more electrons and has transferred those electrons to the non-metal, the negatively charged one. Okay, in a covalent compound, though, the electrons are not transferred, remember, like when we drew Lewis electron dot diagrams, the electrons are shared between the atoms. And that's why when we did electron dot diagrams and we counted the electrons in the bond for both atoms because they're sharing those electrons. So because they're sharing electrons and they're not just you take that electron, give me that electron, there's lots and lots, there are thousands and thousands, if not millions upon millions, of different ways that these non-metal compounds, these covalent compounds, can form. Okay, with NaCl, with an ionic compound like NaCl, there's only one way that sodium and chlorine can combine. Okay, one sodium, one chlorine. Okay, but in a covalent compound, because again, they're non-metals and they're sharing electrons, there's a huge number of different ways that, again, two different elements can combine. For example, carbon and hydrogen can make what's called methane. It can also form C2H2, which is called ethylene or acetylene. Okay, C3H8 is propane. C4H10 is butane. C6H6 is called benzene. And again, that's just a list of 5 of them. Again, there's hundreds, if not thousands, of just carbon-hydrogen compounds alone. So there's lots and lots of different ways you can name them. Now, there are 2 different ways to name them. One of them is using what's called the organic way. All the names that I just gave here are using the organic way. This is not organic chemistry. Okay, we're going to learn the simpler way of naming these covalent compounds, which is down here in italics. So when you name a covalent compound, you use the appropriate prefix before each nonmetal, and then just like ionic compounds, you change the name of the last one to IDE. Okay, so again, kind of like the polyatomic ions, here are the common prefixes. You don't need to know anything higher than 10. So it does go mono, di, tri, tetra, penta, 1 through 5. And again, hopefully a lot of these you're familiar with, like Tetris. Like the game Tetris is made up of 4-sided figures. Obviously a triangle has 3 sides. A pentagon has 5 sides. A hexagon has 6. The way I remember actually number 7 and number 10 is actually from the Olympics. Okay, in the Olympics they have what's called a heptathlon and they have a decathlon. And the heptathlon has 7 events, and the decathlon has 10. Okay, oct is 8, and then nona is 9. So, how do you use those prefixes? Okay, let's look at our first example. It says write the name of C2H6. So we know C is carbon and H is hydrogen. So we know it's going to be carbon, and the hydrogen, remember, change the ending to IDE. So it's going to be carbon hydride. Don't do hydroxide, because remember, hydroxide was back with our ionic compounds. Okay, so we've got carbon and we've got hydride, and then we have to use these prefixes here to determine how many carbons and how many hydrogens there are. Because again, there's not just one way to put them together. There's hundreds and hundreds and hundreds. Okay? So that's where the prefix comes in. So the prefix for 2 is di, and the prefix for 6 is hexa. So how do we name this? We name it dicarbon for 2 carbons, and then hexahydride. Okay? Oh, that's not too bad. Okay, the problem is I'm going to try to mess with you, and I'm going to give you things like this. And I'm going to say, what's the name of that? And you're going to go, oh, well, duh, that's tricalcium diphosphide. And I'm going to say wrong. Okay, because this is a metal, this is a nonmetal. This is an ionic compound. With ionic compounds, you do not use those prefixes. Okay, and again, that's why it's so important at the beginning to go, oh, wait a minute, that's an ionic compound. The name of that is just calcium phosphide. Okay, you do not use prefixes ever with ionic compounds. Okay, example number 2, PF5. So P is phosphorus, F is fluorine, and it becomes fluoride. Notice that there is only one phosphorus atom. So the prefix for 1 is, as you can see up here, mono. The prefix for 5 is penta. So this should be named monophosphorus pentafluoride. However, when the first element only has one atom, you don't write mono on the first element. You do if it's the second element, but you don't on the first element. So instead of monophosphorus pentafluoride, notice it's just phosphorus pentafluoride. And you know that if it's just the name of the element on the first one, there's just one of them. Okay, now on example 3 though, notice that we've got 1 carbon and 1 oxygen. Okay, so like in the previous example, there's that 1 atom of carbon at the beginning, but since it's the first element, you don't put mono on the front of it. But because there's also 1 oxygen, you do put mono on that second one. And notice that when you do put those together, you've got mono and you've got oxide. Notice you'd have a double O there. Notice you just take one of those out and it just becomes monoxide. Okay, so notice that the O at the end of mono and the O at the beginning of oxygen just combine to one O. So CO is carbon monoxide, and that monoxide tells you there's 1 oxygen, which again is different from CO2, which is carbon, look at the prefix, carbon dioxide. Okay, so CO2 would be carbon dioxide. Okay, and then going backwards, this is even easier. Write the formula if they give you the name, tricarbon octahydride. So first of all, tricarbon. So we know it has carbon, and hydride, it has hydrogen. And then how many are there? Well, tri stands for 3, and octa stands for 8. Okay, and earlier when I said the name of that, I said the name is propane. Again, that's a different naming strategy that is using what's called organic chemistry. Again, don't worry about that for now, or in this class at all. Okay, example 5. So let's go through these. Again, this might be a good time for you to stop, practice a little bit, make sure you understand this, and then you can check your answers with mine if you want to pause the video and test that out. Okay, so letter A, the correct name of that would be nitrogen trihydride. Letter B is dinitrogen tetra oxide. Tetra meaning 4, di meaning 2. Here's water, right? H2O. Okay, and we again use that same logic. It'd be dihydrogen monoxide. Okay, and if you want some fun, go into Google and type in dangers of dihydrogen monoxide. And there's lots of like fake websites about how dangerous this chemical dihydrogen monoxide is. Like if you ingest it, it will kill you. Well, if you ingest it, if you breathe it, I should say, it's like drowning. The water's going into your lungs, so you drown. So there's just some funny websites that talk about the dangers of dihydrogen monoxide, for people who may or may not know that it's really just water. Okay, letter D would be silicon dioxide. That's the chemical formula of sand. Okay, and then oxygen. Notice I'm never putting mono on that first element. Oxygen difluoride. C4H10 would be tetra carbon. And then remember 10, like the decathlon, is decahydride. The more common name of that is butane. Okay, again, don't worry about that. Okay, letter G, boron trichloride. And then H would be sulfur tetra, not fluoride, oops, iodide. Okay, sulfur tetraiodide. Okay, and then over here on the right-hand side, again, I'm just looking at the prefixes. So C6H6. Xenon, notice if there's no prefix in the front, we know there's one of them. So that's XeBr4. Dicarbon, C2. Dihydride, H2. Nitrogen monoxide is just NO, NO. Disulfur would be S2. Cl7, right? Hepta meaning 7. Arsenic pentafluoride would be AsF5. Triselenium would be Se3. Iocta 8. And then carbon monosulfide would be CS. Okay, now a lot of times what happens when the numbers are bigger than 10, like C5H12, that's a real compound. Or what if there's more than one element, more than just two elements in there, like CH3OH? Or what if both of those happen? What if you got 3 elements and they're all more than 10? Well, then the rules that we just learned don't apply. You're going to use what's called those organic nomenclature rules, which again we don't cover in this class. But just for your own sake, C5H12 is called pentane, CH3OH is called methanol, and that is just our regular good old-fashioned table sugar, sucrose, C12H22O11. Okay, so at this point we're going to stop, and I'm going to do the next examples in a separate video because it is combining all of them together. So this video is just about covalent compounds. Let's go ahead and practice some of that now.